Let us continue our discussion on logarithm. In the last lecture, we talked about this property here that if I have got m into n as my argument, I can write this as log m to the base a plus log n to the base a, right? So this product became this summation, okay? Now, if I have in place of this n, let us say I have got m into 1 by n. So this same rule can be applied on this also, and I can write it as log m to the base a plus log 1 by n to the base a, right? And further it can be written as log a n raised to power negative 1. And we have already discussed in the last lecture that power of an argument can be taken outside. So finally I am going to write it as log m to the base a minus log n to the base a. So this expression here, which is nothing but log a m divided by n, right? So this division got converted into this subtraction. Okay, so this is just an extension of the rule that we studied in the last lecture. Let us move further and talk about a very important theorem in this chapter, base change theorem. Now in this theorem, we can change the existing base to whatever we want, right? It should be allowed, obviously, it should be defined. For example, if I've got an expression like this, log b to the base a, and I want to convert it into an expression that has got a base c. So what I'll do is, I'll write it like this, log b in the numerator divided by log a in the denominator, and write the new base. Okay, let me take another example. For example, let us say I have got m here and n in the base, okay, but I want p as my base, so I'll write log m divided by log n and p as my new base. Okay, so we will prove this. This is a very simple theorem to prove. For example, if I take this expression here, log b to the base a as x, so using the basic definition, I can say a raised to power x is equal to b, right? This is nothing but the basic definition. Now, if I take log on both sides, if I take log on both sides, and how will I take this log? I'll take this log with the new base that I want. So log a raised to power x to the new base c is going to be equal to log b to the base c, right? Now see, from this expression, I've got x as power of my argument, so I can take x outside, so I can write log a to the base c into x equal to log b to the base c. And from here, what is x? X is equal to log b to the base c divided by log a to the base c. Alright, and what was x? X was our original expression, which is equal to this expression here. So I have changed the base and I've shown you the proof also, right? It is more of an observation than a proof. Okay, so there are various usages of this base change theorem, right? For example, if let us say you have got an expression like this, log b to the base a, you can convert it into an expression, or you can write it in another way, 1 by log, now the argument will become the base and base will become the argument. Okay, in all these conversions or manipulations, I am already saying that it should be defined first. It should be defined, right? And when I say it should be defined, both sides should be defined. For example, if I take b as 1, if I take b equal to 1, this left hand side is defined, very well defined, right? But 1 is not defined on the right hand side. B equal to 1 is not defined here because b is in the base on the right hand side. So when I am mentioning these conversions or manipulations, I am automatically assuming that you know that both sides are defined, right? Only then these conversions are possible. These conversions are possible. All right. So you can change the base into argument and argument into base, right? Like this. Now, how can I prove it? Just by using base change theorem. So I can write this expression here like this. Log b divided by log a, right? And now I am changing the base to base b, right? So I have to change it in the numerator as well as the denominator. Now what you observe is that the numerator has become 1 because base and argument have become same. So this will give us value 1. So it is nothing but 1 by log a to the base b. I hope this conversion is clear to you. I have just used the base change theorem to do it, right? So we can do it with other expressions also. For example, if I have got, let us say, log b and I have got some power of my base, okay? So now the base here is raised to power k, okay? I will show you that you can take the power of base outside but in the denominator. So this expression here can also be written as 1 by k into log b to the base a. We have just seen in the previous lectures that if, let us say, I have got some power of b, right, or some power of the argument, I can take it outside and write it like this, n log b to the base a. But now in this particular rule, I will show you that you can take the power of base outside, but it will come like this in the denominator. Okay, so let us take another example here. For example, I have got p here, q raised to power, let us say, n as my base. So I can write it 1 by n log p to the base q. Okay, so this is another application of base change theorem. We will change the base of this expression to a new base which is a. You can see on the right hand side, right? So what will I do is, using base change theorem, what will I do is I will write it like this: log b divided by log a raised to power k. This is how we write it. Then the new base, I am taking the new base as a, new base as a. Now if you observe, the denominator is nothing but k, right? We have studied this kind of expression. So the denominator is k, so I can write it as 1 by k, and the numerator is nothing but log b to the base a, which is the required expression. So what have we learned so far? That if you have got some power of argument, let us say you have got some power of argument and some power of base, you can take out these powers like this. You can take power of argument outside simply like p, and you can take power of base outside, but it will go in the denominator. So you can write this expression like this: log b to the base a, right? So I hope this expression is clear to you, and there are few more usages like this. Let us say you have got an expression log b to the base 1 by a. So what you can do is you can write it like this: log 1 by b to the base a. Okay, this is a simple conversion which can be explained by this rule that we have just studied, because this expression is nothing but log b to the base a raised to power negative 1, right? And power of base can be taken outside, so it will go in the denominator, but for this example it doesn't make a difference. Anyhow, I have written it in the denominator for the clarity, so we can write it like this, right? I've just taken the power of base outside, and now I can take this power on b, right? So I can write it like this: a b raised to power negative 1, which is nothing but log 1 by b to the base a. Okay, how did I take it on b? Because we can, right? We just studied that we can take power of argument outside as it is. So we can take the number or constant written outside on the power of b also, right? So these are some of the usages of base change theorem, right? We will continue our discussion on logarithm in the next lecture.